All right, we're going to write the chemical equation for the reaction of the combustion of isopropanol, also known as isopropyl alcohol or rubbing alcohol. All right, so all right. Well, normally we'll give you the formula. So it's all right. So sorry, we would give you the formula for something that's not so obvious like that. All right, so we're going to start with the hydrocarbon, and to have a combustion reaction or to have anything burn, that's going to require oxygen, and that's going to produce in a complete combustion. It's going to produce water and carbon dioxide. All right, so now let's balance this. I'm gonna actually let me do this in different color. I'm going to separate the reactants from the products, and just starting with the reactants, list all the elements I see. I see a carbon, hydrogen, and now I see oxygen in two places, so I'm going to make two separate lines for these two oxygens, and the reason is I can put coefficients in two different places. That's why. All right, so let's count these up. There's 3, 8, there's 1 over here, so got to keep track, and then there's two over there. Now, over on the right-hand side, the product side, regardless of how it appears in the equation, I'm going to put them in the same order because I want to be able to compare side by side. All right, now on the right side, oxygen also appears in two different chemicals. So again, I'm going to need two different lines. All right, and then carbon, there's 1. Hydrogen is 2, and this oxygen is going to be my next one here, 1, and this oxygen I'm going to count down there. Well, my last line is 2. All right, so a general strategy is balance the element that is isolated. Do that last. Generally speaking, it's going to be easier to balance, and the element that appears only at one place on both sides, you can do that first. That's either the hydrogen or the carbon. Let's see. Do we see any? I guess you know what? I'll do carbon first. I think doing hydrogen first may work out better, but I think most students would just do carbon, so I'll do that first. All right. On the left we have 3. On the right we have 1. So let's. Yeah, we're gonna have to go through this a couple times. All right. We're gonna multiply the carbon on the right, so that's right there by 3. All right. To get both sides with 3 carbons. Now, before you move on, make sure you also update the every other element in that compound. All right, so again, keep track. That oxygen is down here. All right, so that we're going to update that with 6. Okay, so we see the carbons are done. The oxygens, I'm sorry, the hydrogens, let's work on that next. So we need to multiply the right side where we see hydrogen, that's right there, by 4. In order to get 8 on both sides. Now, 4 times the 1 oxygen there is going to be 4. So now this is what I kind of saw earlier. When you multiply an odd number, actually let's just keep going here. So the carbons are checked out, the hydrogens check out. We have more oxygens on the right. We have a total of 10, and we have 3 on the left. Okay, but the problem is this is an odd number, and there's we're gonna have to multiply that to get an even number. All right, because there's no number you can put here. All right, there's no number to put here, right there, and get 10, because this can only produce an even number, and this is always going to make it an odd number. So that's what I'm trying to say. Maybe could have said it in a clearer way. All right, but we need to multiply this by through, and so the most obvious thing you would do is just multiply by 2. You know, so that way this will turn into an even number. And we're gonna have to go through this a second round here. All right, I'll do this. Do a different color. All right, so let's multiply through by 2. All right, so that's going to be 6 carbons. Multiply that by 2. That's going to be 16 hydrogens, and this is the oxygen. We're going to multiply by 2, and it's going to give us 2 oxygens. All right, now we're going to have to do this over. All right, should we? Yeah, let's just erase this. You know what? I don't have an eraser. I can't find it. I'm going to just keep going here. All right, so we're at 3. All right, let's multiply that by 2. All right, so that's 2 times 3 is 6. So this is going to be 6. Oh, here it is, 6. All right. You know what? Might be easier to see that. 6. All right, 1 times 6 is 6. Okay, now let's multiply that 6 to that oxygen. All right, so just, sorry, I can't find my eraser. All right, that's the one down here. Times 6, it's going to give us 12. All right, now let's work on the hydrogen. We have 16 on the left. All right, let's just start over. All right, so 2 times 8 will give us 16 hydrogens. Well, that'll balance that out. All right, so let's change that to an 8. All right, now we need to also update that oxygen. 8 times 1 is 8. All right, now we have, now we're down to our final step. We just plug in the correct number here. What do you think? All right, well, on the right side we have 20 oxygens total. We don't want to change that again. Oh man, do it all over. So, all right, we already have 2. What number do we need here to get it to 20? We need 18 more, so we need to multiply by 9. Right, 2 times 9 is 18. Right? 18 plus 2 is 20. So that's a 9. Final answer is 2986.